Hey guys, welcome back everybody. So today we're going to talk about something interesting about the DMVPN Phase 2, right? What people think about the Phase 2. Let me quickly recap the Phase 1, Phase 2 and Phase 3. So normally in the Phase 1, what happened? You can achieve the communication between the spoke to hub and then spoke, right? So let's say example, we have router number 2 and router number 4 right now. If they want to communicate to each other, then my traffic will go by the hub router, right? Not to deny that, the Phase 1 people are still using in the production network, right? Do not think about the phase one is a bad configuration and the bad implementation people are using in the production network. If I talk about in the phase two, right? In the phase two, what happened? We can achieve the spoke to spoke communication, right? So we will have a dynamic tunnel between the data 2 and data 4. Amazing one. In the phase three, what happened? We are achieving the same thing, spoke to spoke communication. Now the thing is that in the phase two, what happened? We are tweaking the routing protocol, right? We are manipulating the routing protocol over here. And in the phase three, what happened? We are manipulating the NHRP protocol. Now, many of the network engineers has always confusion about the phase two. People are not using the phase two. It is not recommendation to use the phase two. This is the myth is going on in the market. Now, let me explain you this topology right now. And in this topology, what happened? We have a requirement of the phase two, and without phase two, we cannot implement this feature. So let's say example, understand this topology first of all, right? I have a hub site. This is the NHS next hub server. That's in the Hyderabad right now. And then we have a spoke one, that's our Delhi site number one. And then we have a site number two. So site number two, that's in the Bangalore, right? You can see that, right? At the enterprise side, we have a two routers. We can call it the dual homing connection we have right now over here. The reason to use the dual homing, if the one router goes down, I can still send the packet via the another path, right? So that's why I use the dual home. Same way, what happened the site to the Bangalore, I have a dual homing connection over here as well. So now what happened in that case, right? This network that you see behind the R2 and R3, we have a LAN network 23.0/24. And between the router 4 and router 6, we have a 46.0/24. These two network, right, R2 and R3 is going to advertise to the R1. So on the router number 1, what happened? You will have this route 192.168.23.0/24 from the R2 as a next hop and R3 as a next hop. Same thing would happen. Router 4 and router 6 is going to advertise this route to the router number 1. So on router number 1, what happened? You will have these route 46.0/24, right? As the next hop will be router 4 and router 6. Now the interesting part, what hub will do that? Will hub advertise both the subnet to the site number 2? So this is the subnet we have 23.0/24. Will the hub advertise this 23.0/24 to the site number 2 from both the site R2 and R3? Let's check it. So what we can do that, first I'll configure the basic DMVPN configuration, right? So my underlay configuration, right, it has to be there because DMVPN is an overlay technology. So we need to first have an underlay configuration, right? So for the underlay, what we can do that, we are going to configure any of the routing protocol. You can go with the static route as well. So I'm going to configure the default route just to make a underlay connectivity right now. Right. And on the overlay, what happened? I can use the EIGRP protocol. Okay. Now you can see on the notepad what I can do that. I'll start my configuration. So on router number 1, right, we have a config terminal interface gig 0 by 0. I have a 12.1.15.1/24, no shutdown. And interface loopback number 1 IP address, we have a 100.1/24. This is my private network we have behind the LAN. And then I have a default route, which is pointing to the service port. All good. This is my router 1 has done. On my router number 2 right now, we have a config to interface 0 by 0. I have a 12.1.25.2/24, no shutdown. And I have an interface gig 0 by 1. So if you see that this interface right now, we have a gig 0 by 1. That's my LAN interface running with the 23.subnet. All good. And that's all. And I need to configure the default route as well on 25.5. Now, if I talk about R3, on R3, we have a similar configuration, right? I have a 35.3, right? This guy should be go with the 23.3. And the default order I have should have a 35.5. That's pointing to the service provider. R4 as well we have. On R4 we have a similar configuration. We just need to manipulate some IP address in 45.4, right? This link will be 45.4. And then we have a loop back, interface, LAN interface. It should be 46.4. That's good. And the LAN network, the next hop we have 45.5. So you can see that this is the next hop. We have a ISP router interface IP. On router 5.6 as well, we have a config terminal. Copy. And I just need to manipulate this guy. So this link we have, you can see that it's a 56.6 right now. Right? And my LAN interface, it should be 46.6, and my next hop will be 56.6. So this is my step one. In the step one, what happened, we have set up the underlay configuration, configure the IP address and routing, underlay routing. Right. Step one is done. So let me take a control of all the router and configure the step one, and then we'll verify the reachability as well. R2. So this is the biggest myth people has it regarding the phase two, that phase two people are not using in a production network. But I'll show you the use case that you can understand the logic behind it. Oh, what happened to router 4? Switch B has some problem. Ah, it's a switch A trade. And then we have router 5 as well. So my all the router is working good right now. I will copy and paste this configuration. Hostname router 1. R2 we have. No. R3 no. R6 I said no, and R5 is working good. R4 is missing right now. Let me turn on this guy. Come on. I'll copy this config on the R2. All good, right? Hostname R2 is done. And now we have R3 as well. So all these are my routers that you see right now. These are my spoke router, a client router. So you do the routing configuration only on the client router. On the service portal, we are not going to do anything. We're just going to configure the IP address. That's all. So R4 is 3 is done. Now we have to go with R4. And here we have R4. No. Meantime, I'll configure the R6, right? R6 we have. Config terminal hostname R6. And here we go. Okay. It's a 56.5. That's my wrong configuration. Now we have a router 4 back again. Here. All good. Hostname R4. That's good. Now we need to configure the ISP router. That's my router 5. So I'll configure it in the notepad. Only the IP configuration I have. So the gig 0 by 0 is 12.5. 12.1.15.5, right? And then we have a gig 0 by 1. This would be the 12.1.25.5. And then we have interface gig 0 by 2 will be the 12.1.35.5. and interface gig 0 by 3, 12.1.45.5, right? And then we have on gig 0 by 4, 12.1.46, not 46, 56.5/24, no shutdown. So on the ISP side, we just configure the normal IP addressing, right? I have router 5, and here we go. My configuration has been done. So what I can do, that the first and basic thing, right? So whenever you're gonna configure any overlay technology, right? Doesn't matter you configure the GRE, MGRE, DMVPN, VXLAN, SD-WAN, SDXS, ACI, anything you're doing that. It is always a great suggestion that you should check your underlay configuration and underlay utility, because if your underlay is not gonna find, right, then you cannot achieve the overlay, right? So better to check the underlay and then start doing the configuration of the overlay as well. So from router 1, what I can do that, I'll make a ping, right? So router 1, I'm gonna make a ping to the R2, ping 25.1. Sorry, 12.1.25.2, right? From here to here, I should able to ping. Then we have a 35.3 as well. All good. Ping, we have 45.4. Working good. And finally we have a 60 R6, 56.6. My ritual is working good right now between the hub to spokes. What I can do that now, I'll configure the step 2. Step 2, we need to configure the DMVPN. On router number 1, I'll configure the tunnel 1. So if you see that this is my tunnel IP addressing that I'm going to use it. It's a 192.168.1.1.1, right? This guy's a 1.2, this guy's a 1.3, this guy's a 1.4, and this guy's a 1.6. IP address will be 1.1.1, and tunnel source will be, oh, come on. Tunnel source will be gig 0 by 0. Do not put the no shutdown command. It's not mandatory in the logical interface. Tunnel mode will be GRE multi-point, right? So once I'm going to put the multi-point command, automatically what happened, my tunnel will be up. Okay, that's all. IP and HRP network ID by default, NHRP is disabled. So I'm not going to explain you the DMVPN concept right now over here. I'm assuming that you should know the DMVPN. We'll make a separate video on the DMVPN as well. But here I'm assuming you should know the DMVPN. You have a complete idea of the DMVPN phase 1, phase 2, and phase 3 as well. IP and HRP network ID you want. This is the locally significant number we have. IP and HRP map multicast dynamic. Right? That's all. This is the hub configuration on the router number 2. That's my spoke router. We have a tunnel number 1. This is the 1.2. Remaining part is same because R2 has a same gig 0 by 0. Multi-point and multicast dynamic. I'm going to put the physical IP address 15.1. IP and HRP NHS will be 101, and IP and HRP map. If I want to send the packet to the 101, I need to send the packet to the public address. Right? So this is a static mapping that we have done on every spoke router. One of the good part of the DMVPN is what? You can copy and paste the configuration. Just change the IP part. The remaining things are same. R4 as well. So this is the R4 is done. That's my IP 1.4. This my R3 is done. That's my IP is 1.3 right now. And then finally we have router 6 as well. R6 we have a 1.6. So if you see, right, so router number 2 right now, we have a IP 1.2, remaining part are same on a R3 as well, because everyone has a same source interface, gig 0 by 0, gig 0 by 0, and gig 0 by 0. Okay, so I'm using over here as a interface number. You can use the physical interface IP address as well. It's up to you. Right? So that's good. On the router number 1, I'm copy and paste this configuration, right? So R1. Here we go. My configs are good. On R2. So once I want to configure the R2, right, then what happened? R2 is going to send the NHRP registration request to router number one, right? So every spoke router, or we can say client router, is going to send the request to the server router. Hey, this is myself, and I'm going to register myself to you. On R3 as well. On R4 as well. This is the same approach you can also follow in the CCIE lab exam as well, right? Copy and paste this configuration. That's going to save your time. And the router 6 as well. Okay, right. My DMVPN is configured now. You can check on the router number one. You should have a all dynamic mapping, right? So you should have a 4 dynamic mapping, because you're gonna get the dynamic mapping from R2, R3, R4, and R6, right? So 1, 2, I'm getting the dynamic mapping. 1, 3, I'm getting the dynamic mapping. 1, 4, I'm getting the dynamic mapping. And 1, 6, I'm getting the dynamic mapping. All good. You can also see the SO DMVPN, right? You can see that I have a 4 tunnel right now, 25.2 the 1.2. These address that you see, this is called as a NVMe address, right? This is called as a tunnel address. This is called as a NVMe address. 35.3, 45.4, and the 56.6 as well. My everything is working fine. This attribute D means it's a dynamic right now. The same time, if you go on the router number 4 or any of the spoke router and put the command SO DMVPN, you will have a static mapping, right? So every client router, right, will register itself to the hub router. Now, the step number 3, we need to configure the routing. Configure EIGRP over tunnel. Now, here I'm going to configure the EIGRP name mode, right? There is a reason behind it. Because the feature that I'm learning right now, because I want to achieve the ECMP, right? I want to achieve the ECMP between the LAN network, right? I want to achieve the ECMP between the LAN network. And for that reason, what happened? I need to use the feature, right, which is called as a EIGRP Add Path, right? It is only gonna present, it's only present in the EIGRP name mode, right? So many of the things, right? So, is present in the name mode only. So let's example, even if you're planning to configure the FRR, right? You can only do in the name mode. So this is also a reason, right, why you can move to the classic mode to the name mode. Because classic mode is a classic, right? It's a old. So whatever the new features are coming in nowadays, it's all are coming in the name mode only. So what I can do that, I'll go and configure the name mode. So on the router number 1, come on. Router EIGRP, I'll give the name as a CCIE hub. That's my name. And address family, IPv4. Okay. By default, the unicast keyword is taken. So autonomous system 1, right? And I'm going to put the command network. That's my tunnel network. And my LAN network as well. On R2 as well, I'm going to put the same configuration. So on R2, my LAN network will be 23.0 and my tunnel will be the same. On R3, this guy will be LAN network 23.0, tunnel will be the same. This guy will be 46.0, right? And the R6 now we have a 46 now. So all good. Copy and paste this configuration now. On router number 1, so it will form the EIGRP neighborship because I do have a mapping for the multicast as well. So if you see the SO IP and HRP multicast, and I have a multicast mapping. If you don't have a multicast mapping, you cannot achieve the neighborship between the EIGRPs, right? So whenever you're gonna run the IGP protocol like a OSPF EIGRP and you have a dynamic neighborship, in that case you must have a multicast mapping, right? And this multicast mapping requires this command line. It's a mandatory. it's not mandatory in the BGP protocol. So on data number 1, I have this guy. On data number 2, on data 3 as well. On data 4 as well. Data 4 and data 6. 6 have the same configuration, right? My EIGRP is up now. If you go on the router number 1, that's my hub router, right? So I EIGRP neighborship, and I should see the neighborship. Okay, all good. So there's a Q count is 0 right now. It means that we have get all the reliable packet. I mean, so we get the all the acknowledgement of reliable packet. Now, sometimes what happen when you configure the DMVPN in your lab environment and the CCL lab exam as well. So sometimes what happen, some packet gets stuck in the queue, right? So normally what you can do, that is simple process, because I'm not going to explain you right now all these things because the video will get longer otherwise. Flap it. That's a simple way, right? Now, if you see I do have a neighborship right now and I can see the route, do show IP route EIGRP. I'm learning it. Amazing. So R2 is sending the route to the R1 and R3 is sending the route to the R1. We came to the same scenario, right? We started the video from here, if you remember that. I told you that, right? So you receive the 23.0/24 subnet from router 2 and router 3. Same thing, you receive the 46.0/24 subnet from router 4 and router 6 as well. Right? So I finally have a route on the router 1, but if you see on the any of the client router 4, right, I do have a neighborship, right? So IP HRP neighborship, I do have a neighborship with the hub router, and I should receive the route from the hub only, not from the spoke router. It means that, right? It means that the Bangalore branch can communicate with the Hyderabad branch, no problem, but Bangalore cannot communicate with the Delhi because I don't have a route for the Delhi. The reason is only that because I need to disable the split horizon rule, right? So I need to go to the tunnel interface. Let's go to the router 1 and do show run section EIGRP, right? I'll configure this guy. I'm so sorry. Oh, that's fine. Right? AF interface, tunnel number 1. So then no split horizon rule. That's all. Right? By default, split horizon rule is enabled. So we need to disable the split horizon rule, right? And now we get the route. Now, again, point is what? This is the phase 1 right now, right? I need to achieve the phase 2. Why do we need a phase 2 right now? Because I want to perform the ECMP between the LAN. So if I want to use the ECMP between the LAN, right? If I want to use the ECMP between the LAN, I should have a next hop of the LAN spoke router, not to the hub router. So if you see right now on the router 4, I'm getting this route 23.0. The next hop is a hub router right now, not the spoke router. So by default, what happened? EIGRP does manipulate the next hop. Understand this logic right now, router 1 and router 2 and router 3 right now. This is my 12.1 and 12.2, and this is my 23.2 and 23.3 right now. So if you have a router 1.0.0/8 right now, R1 is going to send this route to the R2. So when is this guy's going to send the route to the R2, it's going to put the own next hop. So on the R2, what happened? My routing table I have, our next hop will be 12.1. When R2 is going to send this route to the R3, R2 will modify the next hop. It's the 23.2 now. So when you check the routing table of R3, you will have a next hop will be 23.2. So by default, the EIGRP do manipulate the next hop. What I'm going to do that, I'm going to tell the hub router, because if you see right now on the router number 1, I have a 23.0/24. The next hop is the R2. But when I'm going to send this route to the R4, my next hop will be R1. So I'm going to tell the hub router, hey, listen, do not modify the next hop. My router gets stuck. Okay, sorry, there was an internet issue, right? Let me connect it back again. So I was saying that I need to configure the next, so I need to disable the next hop behavior on the hub router because by default, EIGRP will modify the next hop. So I need to go to the hub router, router number 1, and say this guy, no next hop self under the tunnel, right? So once I'm going to do that, what happened now, if you see on the router 4, my next hop has been modified. So my next hop is a 1.3. But still the problem is what? If you see, understand this logic right now, this client router, right, and this client router is both are sending the update to the hub router right now. Same way, what happened? This client router and this client router is sending the update to the R1. R1 has no problem, right? R1 has no problem. So if you see on the routing table of R1, I'm receiving the route 23.0 from R2 as a next hop and R3 as a next hop. That's good. Same way, R1 is receiving the 46.0 subnet from the R4 and R6 as well. Again, no problem. It means that on the hub router, if I see that, hub can perform the load balancing, right, for Delhi site and the Bangalore site. So if you see the do show IP route EIGRP, right, I can perform the load balancing between the Delhi and the Bangalore as well. Question is that, can I perform the load balancing between the site to site? So if you see on the Bangalore branch, right, I'm just receiving the route from the 1.3. Same way, if you're gonna look for the R2 as well, right, I'm just receiving the route from the 1.4. Why this thing is happening? Understand this logic right now. So I'm sending the route because I do have an relationship with the hub. So I'm sending the route to the hub, right? I'm not sending the route directly from R2 to R4, right? And R4 is not sending the route directly to the R2. I'm sending the route R2 to the hub, and then hub is advertising the route to the spoke. So I'm sending the route to you, and you are sending the route to the another guy. It means that the control we have, right? The problem we have, the control we have on the router number 1. This is the problematic router right now. So what happened? Let me tell you. So when you're going to configure the DMVPN phase 2, right? When you're going to configure the DMVPN. So, and when you're going to configure the EIGRP protocol over the DMVPN, in that case, what happened? They only advertise the one best route. They only advertise a simple concept like a maximum path, right? If you remember that. By default, maximum path is 4. But if I'm going to make the maximum path is 1, it's disable the ECMP. Same concept is happening over here. By default, what happened, the hub router is only going to advertise the one best route to you. Even if they have a multiple best path. So if you see, even the hub router has a multiple best path, right, for the 23.0 subnet. And same way the 46.0, I have a multiple best path, 1.6 and 1.4. But to the spoke router, right, I'm only going to advertise the one best path. That's a limitation we have on the hub router. This limitation has been solved by using the EIGRP Add Path feature. It's a simple command, but it has a longer theory, right? So if you go to the hub router, and I can tell this guy, right, router EIGRP. Okay, I just copy the configuration right now. Here's run section EIGRP. And address family IP pure autonomous system number 1. And under the tunnel interface, tunnel 1, I'll simply gonna configure the add path feature. By default, not by default, I can say that. By default, it's a 1. You can configure up to 4. So if you put the question mark, you have only 4 options. I simply gonna configure 4. Once I'm gonna configure the 4, what happened? My EIGRP will be restart, right? Resync will be happen between all the neighbors. And finally, my spoke router is gonna receive the route from both the spoke. So if you go to the router 4, previously I was receiving the route from only one site, 1.3. Now you can see I'm getting the route from the 1.3 and 1.2 as well. It means that whenever the user, right, let's example, this is the guy, and if this guy wants to communicate with this guy, right, they can perform the ECMP. I have both the path. Same way, if you see on the router 6 as well, right, show IP root EIGRP, the 23.0/24, I have a next hop as a 1.3, this guy, and next hop as a 1.2 as well, this guy. I can do the ECMP. Same way, if you check on the Delhi branch on the router 2, show IP root EIGRP, I have a 46 I'm learning from the 1.6 and 1.4 as well. And this is the use case of the phase 2. I'm telling you, it's not possible in the phase 1 and the phase 3. Now, if somebody will tell you there's no use case of phase 2, show this video to them and share this knowledge to your friends as well. Okay, before I'm gonna conclude this session, right, I'll show you this thing in the Cisco documents as well. You can also gather these documents from the Google, right? I have this documents downloaded right now. Somewhere is that? Come on. Yep. So you can see this same theory you can also encounter, right? Come on, where's that? Yep, here we are, right? So add path support feature that's you're gonna use in the DMVPN, right? So the first of all, for the add path support feature, what happened? You have to, right, by default, the next hop help is enabled. You need to disable the next hop help, right? So once you're gonna disable the next hop help, then what happened? You can enable the add path feature. So if you see, this line is saying that before you configure this feature, the add path feature, right, in the DMVPN domain, you must disable the next hop self command that is configured on the hub interface, right? That's going to help you to achieve the phase 2. So add path feature can be enabled on in EIGRP name mode only. So you cannot do in the classic mode. And some limitation also we have. So the variance command should not be configured when the add path support is enabled in the EIGRP, right? Because the variance command is going to alter the matrix as well. Anything else? You can follow this documents as well for the more information if you want. And thank you so much, guys. I'll see you guys in the next video.